Hey YouTube, welcome back. Today we have this problem number 35, search insert position. The problem is been asked by Amazon, Google, Apple, Adobe, and Opera, and you can see even more. But in the last 6 months, it has been asked by these companies. Let's close this one. The problem said that it's given a sorted array of distinct integers and a target value. We want to return the index if the target is found. If not, we want to return index where it would be if it were in order. We must write an algorithm with O log n. So they want specific algorithm. The solution wants specific algorithm. So let's just say that we have target 5, we have this array, number 5 is index 2, return the index 2. We have 2 here, we can't find 2, however we return the index that where 2 should be. We have number 7, we can't find 7 here, anyway we return the index where 7 should be. And because of the time complexity is O of log n, I guess we should only use binary search solution. So what is a binary search solution? Let's go to the this is from the previous video that we talked about, the cracks your system design interview. Watch this video, it's a good one. So let's just go to the board here and try to okay, so let's assume that we have this one, this input. Let me make it bigger, and because if we want to make it bigger, okay. So if we want to search it, if we want to compare each element by the target, like we can solve this problem into looping through the array and try to compare each element with the target of 5, like 3 and 5, and until we find 5 equals to 5. However, the solution takes its O of n. Not, we want something O of log of n. And to do this, we have only to use a binary search. How the binary search work? The binary search work in this way. We take left, and right, and we have like a range in them. So we take something called a middle, and the middle equals the index of left, the index of right plus index of left divided by 2. And we maybe find a specific index. For example, it will be 3 and 0, 1.5. It will be this 3 first mid, and we try to compare the mid to the actual target. And if the mid is not equal to the target, we ask if the mid bigger than target or smaller than target. If the mid is smaller at this one, as this example, we start to loop in the right section of the array, because it's a sorted array. So if it's smaller than the 3, it will be smaller than all the previous element. So we just continue to loop in this section only, and the mid will be the new start. It will be the new left, and we'll start to, and the right will be the same, and we'll try to find the middle, which will be 5 here. We compare it with 5. When we find it, we return it directly, and this one take O of log n. So let's just start into solving this problem. It will be pretty easy, pretty straightforward, and it's one of the best problems that make it will be like a warm up for you to start working with the binary search solution. So let's just let left equals 0, 0. Let. Sorry guys, I'm not focusing. The let right equals nums dot length, and I will say I will create a while loop. While is left should be always smaller than right. Okay. I will say let mid will equals um, right left, sorry, plus math dot floor um, right minus left divided by 2. And we do add left here because of the numbers can the reference could be 10 10 in power 4, and yeah, because of that we add left. And we say if the target is bigger than nums of mid, we will say left will equals mid plus 1, because we start to search on the right. Else we will say right will equals mid, because we want to search on the left side. And otherwise I will return left. Let's see if this works, and let's just try to describe it. Okay. It didn't work. Why? Let's see why here. So we have right minus left divided by 2, and we have left plus mid equals if target bigger than nums of mid, else right equals mid plus 1, left equals 0, right equals nums length. Why it didn't work? Oh, I have some cases that didn't work at all. Let me delete this one and submit it. Oh, this is not good. This is not good. Why it didn't work? Let me try to see again. Mid equals left plus math dot floor. What is that? Why is it like that? Yeah, okay, I know why not now. Of course. Sorry, it was something wrong. And yeah, I guess right now it will work. Let me see. Yeah. So let me try to run an example to make sure that we understand it correctly between us. Let me just grab this thing down. So I guess most of you will not understand why we add left. Why we add left? We could have math.flow, and actually math.flow solve a lot of problem. However, this line of code is responsible for calculating the middle index mid within the search range defined by right and left. And for example, here we have right minus left. This part calculates the difference between right and left pointers, which represent the length of the current search range. We have the floor, we make sure that we have something that a specific number that like not 1.2, 1.3, because there's no index of that. Maybe the tough thing is that this part, why we have left plus. So finally this one, the mid variable is assigned the value of low plus of left plus the calculated mid index. This positions the mid index relative to the left pointer, representing the position of the middle element within the current search range. So yeah, that was why we add left. You can let's run a test or like an example here. So we have this number, we have 5, so start at least left will equal 0, right will equals 4, and we start here. Mid will equals left, which is 0, and right, which is 4. Left 0 plus floor 4 minus divided by 2, it will be 2. Okay, so we got mid 2 divided by 2, it will be 1. So we said, okay, mid will equals target of mid will equals mid equals 1, so target of mid equals 3. We said that if target of mid bigger, this is not true, so we update right to be mid, so right it will be 1 right now. So right it will be yeah, there's something wrong I have calculated here. If target is bigger, this is not right, so I guess we made right minus left, which will be 4, it will be 2, so it will be exactly 5. Yeah, it will be exactly 5. It will be solved from the first loop. Let's find something different, because this will be solved in the first loop. Let's just find this one. We have 1, 3, 5, 6, and we can find any 7. So let's try to loop through this one. So we say that, okay, let's right will equals 4, and 0 will still be yeah, left will be 0 because it's the first loop. So I will say, okay, mid will equals left, which is 0, mid the flow, right minus left. It will be 4 divided by 2. It will be here, this 5. I will say, okay, this 5 bigger. This is not true. 5 is not. The target is bigger. Yeah, target is really bigger. So what I will say our left it will be mid plus 1, so the mid will be here. So mid will be equals 2. Left, sorry, will be equals 2. So it will be equals 2. So we continue looping again. Left is not bigger than right yet. So we have we loop again. We say, okay, 2 mid will equals 2 plus right minus left. It will be left minus 4 right. It will be 2 minus 2 divided by 2. How much it will be? 2 minus 4 divided by 2. It will be 1. So we'll be at like 1. So it will be 3. So we'll be here. And because we are here, we are here right now. So basically 6 is still less than target, and because 6 is still less than target, we will update left. It will be equals middle plus 1, so it will be 1 2 3 4 0 1 2 3. It will be 4. Left it will equals 4, and because left is no longer smaller than right, the while loop ends and we return 4, as you can see here. So yeah, that's it for this video. I hope you like my solution. If you like my content, make sure to subscribe and hit the notification bell so you will never miss a video, and see you guys in future problems.